Kinematics. Kinematics explain motion of points, bodies and system of bodies without consideration of the causes of motion. A kinematic system or mechanism can be illustrated in three different ways that can help to provide an overview of joints in a given system. Number 1. Mechanism sketch. Number 2. Kinematic diagram. Number 3. Kinematic graph. To explain this, we will take piston and connecting rod example. Mechanism sketch for this system contains frame, crank, connecting rod, and piston. Here you can see kinematic diagram and kinematics graph. To calculate mobility of this mechanism, we will use 2D version of the Kutzback equation. The Kutzback criterion calculates a mechanism's unlocked degrees of freedom, where B equals mobility, N equals number of links or bodies, U equals number of unfreedoms or constraints at each joints. F equals number of identical degrees of freedom. A popular description for B is number of motors required to control mechanism. If B equals O, the mechanism is over-constrained or locked. If B equals 1, the mechanism is free to move, requiring one motor to drive it and control the motion of all links. If B equals 2, the mechanism is free to move, requiring two motors to drive it and control the motion of all links. The sketch shows the links and joints and also specifies the freedoms and constraints for each of the joints. The mobility of this mechanism has 1 degree of freedom, so one input can control all movement of this mechanism. For this system, we can also calculate 3D mobility by using all 6 degrees of freedom. A table for system constraint can be developed for this purpose to find out mobility and constraints. I have explained 3D mobility calculation in my next video. Thanks for watching.